Oh, you want to read the electrical signals from my brain? Sounds like you could use some op-amps. Op-amp. O-P space A-M-P. Op-amp. Op-amp can also be spelled without the space, O-P-A-M-P, or even with a hyphen, depending on who's saying it, as long as it always means operational amplifier. And that is the least of the esoterica that you're going to hear today. Oh my gosh, op-amps? They were kind of the bane of one of my classes when I was studying bioinstrumentation in college. That's the college class all about making little machines to measure your brain signals, for example, or more likely in the beginning, measuring your pulse by shining light through your finger. Yeah, we created little devices to do that. And this op-amp was a tiny little electrical device that was used to help read in those signals. Whenever you have a weaker electrical signal, like with a tiny, tiny, tiny voltage, maybe on the millivolt level, well, you usually want to amplify it, make it bigger, make it easier to detect and read and interpret. You use an op-amp oftentimes to amplify those signals, including bioelectrical ones. Of course, you can use an op-amp for any electrical signal, doesn't have to be from the body. We use them in all sorts of electronics. And the history of it is not just in my horrible college class. It comes from 1941, where we had vacuum tubes being put together to make op-amps. Op-amps are complicated little devices that themselves are a huge system made of transistors and resistors arranged in a certain pattern so that they will amplify electrical signals. Not only are they systems, they are parts of bigger important systems. Let's go back to the history of me here. So, as a warning, anyone who has not taken an electrical engineering or bioengineering class on electrical components like op-amps, do not be surprised when you encounter them and you may be super frustrated like I was, because it turns out that this little device, you can wire it up in so many different ways. It's pretty versatile to have different behaviors. Typically, the ideal op-amp without anything connected to it, it basically just amplifies an input signal to the max. Like, it's really comparing the difference between two voltages, kind of like an analogy would be the scales of justice. It's the two scales where you put a weight on one side and you put another weight on the other side. And if there's a difference in the weights, like if you put a rock on one side and a rock on the other side of the scale, if there's a difference, what's going to happen? One side of the scale is going to go all the way down. Boom. It's like amplifying that difference in the weight. That's kind of what an op-amp does with electrical signals. You have one voltage going in on one side, another input voltage going in on the other side, and it compares those two voltages. And if there's a difference, boom, there's a really huge output voltage signal. It's kind of like the scales of justice, where if there's a difference in the mass, the height of one side of the scale goes up really far. The magical thing, in my view, about op-amps is if you connect wires and resistors to it outside of this thing, it can do complicated things. You can invert the voltage signal. You can amplify the signal to a very, very precise amount, maybe 10 times bigger, 20 times bigger, 100 times bigger, whatever you need. You can start doing mathematical operations on your signals. Instead of just finding the difference between signals, maybe you can sum signals together, add them together. You can start multiplying, differentiating, calculus anyone. You can start integrating signals. It's kind of crazy. And the way it works is you make op-amps part of what's called a closed loop system. You basically take the output signal and connect it back in, loop it back into the input so that the output affects the input. If we go back to the scales of justice analogy, it's kind of like instead of just a simple mass scale where you put a heavy rock on one side and a light rock on the other and compare the difference. No, instead of that, you have some feedback. You have a feedback loop. It'd be like attaching a spring to one side of the mass scale. Imagine that, a spring connecting the ground to one side of the mass scale. So that if you put a heavy rock on one side of that scale and a light rock on the other side of that scale, what's going to happen? Any difference between the two weights of the two masses on the two sides of the scale would normally cause a big movement in the scales, one side all the way down, one side all the way up, but this time the spring starts to detect that movement. And the further the scales move, the more that spring applies its own forces to the scale. It responds to that scale's movement and puts in its own inputs into that scale. And then the scale becomes in a new equilibrium, taking into account the rocks and how heavy they are and the spring. That's kind of like how an op amp would work in a closed loop system. I don't know if that analogy helped too much in understanding how an op amp behaves. I hope it did, but suffice it to say that op amps and the variety of different circuits that they can be used in are complicated, and learning about them sometimes feels like memorizing why 100 different animals behave the way they do and make the sounds that they make. And you don't know why they make the sounds that they make, but they just do and just deal with it. That's kind of like learning about op-amp circuits. Except in real life, animals are cute, and so that makes it easier to remember why they make the sounds that they make. Op-amps aren't cute. They're just symbols on a page to me. If they are cute to you, like one of my students said years ago in mechatronics, she said op-amps look cute to her, look like little insects. And hey, if that's what you think as well, and you are great at learning about them, you should be an electrical engineer. Op-amp is our engineering word of the day. This has been Engineering Word of the Day. I'm your host, Pius, and if you like what I do, you like this podcast, you like the other educational stuff that I make, please support me on Patreon. You can find me at patreon.com/PiosLabs. And if you forgot how to spell all that, just go to the link in the show notes. I appreciate it.